All right, on this bell work, we got fractions being multiplied, and I see some cross simplification that can happen. So that's what I'm going to do first, all right? And of course, you could just multiply these and then simplify if you'd like, but I'm just going to cross simplify. It's a strategy we really want you guys to get used to because you're going to be using quite a bit in either 9th or 10th grade, maybe both. But I see that the 5 and 10, one in the numerator, one in the denominator. Okay, it always has to be one in the numerator, one in the denominator. They're both divisible by 5 in this case. So I'd say, well, 5 divided by 5 is 1. And then I'd say 10 divided by 5 is 2. Okay, now it has to go into these evenly, so we shouldn't end up with any decimal or fractional values from these divisions. And then I also see that 16 and 4, these are both divisible by 4. So I'd say 16 divided by 4 is 4. And 4 divided by 4 is 1. Now you could multiply and simplify at this point, but I see there's even more simplification between the 4 and 2. So that's what I'm going to look to do right here. So I'd say the 4 is divisible by 2, which would be 2. 4 divided by 2 is 2. And then the red 2 in the denominator, that's also divisible by 2. 2 divided by 2 is 1. So in the end, I get some fraction multiplication. I'd have this 1 times 2, which is 2 in the numerator. In the denominator, I'd have 1 times 1, which is 1 in the denominator. And then 2 divided by 1 just simplifies into 2. Make that a phantom divided by 1. It's still there on this one. We just don't want to show it, and that would be considered fully simplified at this point. Now again, if you'd done 1 times 4 to get 4 in the numerator, 1 times 2 in the denominator to get 2, then you would have seen 4 divided by 2 is 2, same answer, okay? Or some of you may have even had done 5 times 16, which is 80, and then 4 times 10 in the denominator is 40, 80 divided by 40, still 2, okay? So again, the answer ends up being the same no matter which route you take, whether you simplify towards the beginning like I did, or whether you simplify towards the end after the multiplication. It's really up to you. All right, there's our objective for the day. I can change mixed numbers to improper fractions and operate. So take 30 seconds and copy this down, please. All right, so since we need to be able to change these mixed numbers into improper fractions, we're going to be using cycle method on this, which we've seen already. In fact, once we get the mixed numbers into improper fractions, then everything is the same as we've seen before. The operations with those improper fractions are the same as if they were just regular fractions. So when you add and subtract fractions, remember you need common denominators. And when you multiply fractions, just like we did in the bell work, you could do some cross simplification if it's possible. And then division of fractions, remember, we don't actually divide with fractions, we only multiply. So we wouldn't have to use, I think someone called it keep, change, flip, right? You change the operation from division to multiplication and flip that second fraction, the divisor. But do remember, with multiplication and division, you do not need common denominators. So here's proper and improper fractions. Remember that proper fractions have bigger denominators than numerators. Improper fractions have bigger numerators than denominators. And improper fractions can be written as mixed numbers, formally. So if we ever have a mixed number, then it automatically changes into an improper fraction for us to operate with. Now, when we're doing this, and this is just a pure math setting where improper fractions are just easier to use with these operations, you may find in life that mixed numbers are actually easier to use whenever you're doing whatever it is, whether it's construction or baking or something else, okay? But in a pure math setting, we want these mixed numbers to be changed into improper fractions. So this is kind of the format for a mixed number. Remember that it's a whole number with a improper fraction. It's a mixed between the two, which is why we call it a mixed number. And the whole number can be negative, which makes the whole value negative. And then your fraction right here has to be a proper fraction that goes with your mixed number, okay? So we've seen an example like this, where we say, hey, look, we got this whole piece right here, right? It's filled completely. So there's, how many filled pieces do we got? Right now I got one full piece, this one right here, right? Now, the second piece right here is split up. And there's only one piece that's shaded right here. Now, since there's only one piece that's shaded, that would be the numerator. That tells you how many of something there is, in this case, shaded pieces. In the denominator is going to tell us the sizes of the pieces. So how many pieces would make a full circle on this one? 1, 2, 3, 4 pieces. So I end up with a 4 denominator right here. And this is the mixed number. I got one full piece and then one piece out of 4. One full piece, one piece out of 4, okay? So this is how mixed numbers work. Now, some of you would say, well, what if we wanted to change this into an improper fraction? Well, then you'd count the pieces, right? You'd say 1, 2, 3, 4, 5 pieces. And then you'd say there's 5 pieces. How big is each piece? They're all in fourths. So that'd be 5/4. It's the same thing, just written as an improper fraction. And some of you may think, well, where does that improper fraction come from? Even though I don't think most people do. It comes from these 4 pieces right here, right? So that'd be 4 pieces out of 4. And then, well, we still got the 1 piece out of 4 right there, right? See how when we bring these together, we end up with 5/4. Okay, so that's why with cycle method, you got 1 times 4 here. That's the 4/4. And then you add the 1 numerator. That's the 5, the 5th of the 4th. But it does not change the sizes of the pieces. So here's cycle method for us. Remember, we're multiplying the whole value by the denominator, and then you add the numerator right there, okay? Just like we saw in that last example, the whole value tells you how many pieces are filled. And the reason why we multiply this by the denominator is because if you took all these whole parts, whole pieces, and split them up into these many pieces, then that's how many pieces you would have that are this size, okay? And then whatever's left, that's the numerator, that's what we add to that value. So there is a purpose, there's a reason why we do these things, changing mixed numbers into improper fractions with cycle method. And if you can just understand that much, then you can always interpret any mixed number, even if there's labels that go along with it. So let's go ahead and change this, because we need some practice here. Let's change this mixed number into an improper fraction. Now remember, when you change mixed numbers into improper fractions, it will not change the denominator, because the sizes of the pieces are always going to be the same. So I'm just going to put that 9 denominator in there, so I don't have to worry about it anymore. Then I perform some cycle method on this. So again, the whole value, 3 multiplied by the denominator. That means if you were to take those 3 whole circles and split them up into ninths, you'd have 27 pieces. 3 times 9 is 27. And then you add the numerator there, 7, because there were 7 pieces in that last circle. So when I add these two together, 7 plus 7 in the ones place value is 14, carry the 1. In the tens place value, 1 plus 2 is 3. Okay, so that ends up being 34 ninths. The 34, that's a cycle method, remember, that produces our numerator. And then the denominator just stays the same, whatever it is. Now you should always check to make sure that this cannot be simplified. I know 9 is divisible by 1, 3, and 9, but 34 is not divisible by any of those, so this is just considered fully simplified. That's it. Here's 8 and 1/4. Take 30 seconds, try to change this one into an improper fraction, and we'll do it together. All right, here we go. So cycle method on this one. Once again, cycle method does not change the denominator. So I'm still going to keep my 4 right here as my denominator. Cycle method only gives us a new numerator. So I do 8 times 4. It's 8 times 4, which is 32. So again, just interpretation right here. If you take these 8 full circles and split them up into fourths, you'd have 32 of these fourths. But then, you still have that 1 numerator. So you got to add that to those 32 pieces, which would result in 33 pieces. That's our numerator, 33 fourths. And you'll remember that changing these mixed numbers into improper fractions like this, this is just a different way to write it. So remember from elementary school, I know some elementary teachers it's not simplified until it's a mixed number. No, that's not true. These have the exact same value. It depends on your purposes and what you're using them for. Again, since we're in a pure math setting, we want this improper fraction because they are easier to operate with when we're showing all this type of work, okay? So one last thing on this problem that we did here, okay? Now, if by chance the 8 were negative right here, it would just make, I would make the numerator negative, although some people like to show the negative kind of with the fraction line right there, and that's fine. And do expect there to be negative values, but notice that even if the whole value is negative, which makes the answer a negative, the process remains the same. 8 times 4 plus 1. Cycle method, okay? All right, operating with mixed numbers is, as long as you can change your mixed numbers into improper fractions, that's the first thing you're going to do if you have any mixed numbers. If you already have proper fractions, just leave them. If you have improper fractions, leave them. It's the mixed numbers we need to be improper fractions, okay? After you change them into improper fractions, you just operate. It doesn't matter if the operation is addition, subtraction, multiplication, or division. All of those rules are things that we learned, whether it was in 3.1 for addition and subtraction, and then multiplication and division in 3.2, okay? So operations, all those rules are still going to apply, but we need the mixed numbers to be improper fractions first. All right, so here's our first problem, and it does give us some instructions here. Change these into improper fractions and then operate. And yeah, we do not want our answers as mixed numbers. We do not want that, okay? So I'm gonna go in here, and the first thing I'm gonna do is change these two fractions into their improper fraction form. Now that's not gonna change the operation. It's not gonna change the two denominators, so I'm gonna just push those in right there, okay? So I got fourths and thirds, fourths in the first denominator, thirds in the second denominator. And then I will apply cycle method to both, okay? So I'll do this first one in red. That would be 5 times 4, which is 20. And then adding the 3 numerator would be 23. Okay, so that gives us a new numerator of 23 fourths. And then the second fraction, once again, cycle method. So it's 3 times 3 rather, which is 9, and then add the 2 numerator, which is 11. So that is my new numerator for the second fraction. Now again, these are looking a little different because of the numerators, but the values have not changed. 5 and 3/4 is the same as 23 fourths. 3 and 2/3 is the same as 11 thirds. They're just written differently so that we can perform our math operations at this point. Now this is an addition problem. What we need from this addition problem is for the two fractions that have common denominators, matching denominators, or the same denominators, however you want to say it. It's the same thing, okay? So I'm just going to apply the method that we've already seen already. So I'm going to take our first denominator, 4, and I'm going to multiply it by 11 and 3. So I'm scaling the second fraction by 4 here. In the numerator, I have 11 times 4, which is 44. In the denominator, I got 3 times 4, which is 12. Now, if I do this correctly, I should, since I already see this denominator of 12, I should know right now that I should expect a denominator here of 12 as well. So that's what I'm going to do. I'm going to force it to be 12 by taking our denominator 4 and multiplying it by the other denominator 3. But if I do it there in the bottom, I got to do it there in the top as well. So that ends up being 3 times 23, 2. Well, what does that give us for a denominator? Yeah, for 3 times 4, yeah, it's 12. So see, this already shows that they match, which is going to allow me to add the numerators once I figure out the second one. And I don't have my 23 multiplication tables down. So I'm going to have to multiply these. 23 times 3. 3 times 3 is 9. 3 times 2 is 6. And I end up with 69 twelfths plus 44 twelfths. And since the denominators match, I can move on to the next step, which I think, at least last time when I saw, most of you were kind of skipping this step. Be careful if you do that because it seemed like it was causing some problems. And even for the last class that did the homework, it was causing some problems because if you skip this step, then you may get your addition or subtraction mixed up with either multiplication or division. But once those denominators are the same, I keep it the same because I'm not changing the sizes of the pieces. I'm just going to add how many pieces there are. That's from the two numerators. I'm going to take the 69 and add the 44 numerator right there. So again, this does not change the denominator. The sizes of the pieces are still in twelfths. I'm just going to need to add those two numbers. So I'm going to take my 69 and 44, and I will go ahead and add those together. Okay. So in the ones place value, 9 plus 4 is 13, carry the 1. In the tens place value, 1 plus 6 is 7, plus 4 is 11. So I end up with 113 twelfths. And then, of course, you should always check to see if our final answer here can be simplified, because if it can, then you should. Right here, I see at least 12 is divisible by 1, 2, 3, 4, 6, and 12. But 113 is not divisible by any of those, which means that this is already fully simplified. And please resist the temptation to change this into a mixed number because, like I said, sometimes elementary teachers will tell you that it's not simplified until it is a mixed number. But now that we're in a pure math setting, we do not want that to be a mixed number. Just keep it as the improper fraction. Plus, it takes away the need for long division here to change it into a mixed number. So it removes the ability to make those two mistakes right there, as long as you'll just keep it as an improper fraction. So you can see everything that we've done with addition stays the same. The only difference is in the beginning we have to change these mixed numbers into improper fractions. So we're going to continue the same process on this one. This is a subtraction problem, so it will pretty much be very similar to the one that we just did. It's just that now it's subtraction. But with subtraction, just like addition, we need the two denominators to match. Now I don't really care about that right now because I got mixed numbers, and it is subtraction between the two fractions. For now, all I really want to do is change these mixed numbers into improper fractions, and then I can worry about the denominators. But as of right now, since I'm changing these mixed numbers into improper fraction, I got fifths and I got sevenths. Okay, so again, I just write those in right now so I don't forget. And then I can apply cycle method. So for my first fraction, let's start with 5 times 5, which is 25. And then I would add the 3 numerator, which is going to make that 28. So I end up with 28 fifths, 28 for my numerator in the first fraction. The second fraction, again, cycle method here, that'd be 1 times 7, which is 7. And then adding the 2 numerators, 7 plus 2 is 9, gives me my new numerator of 9. So that becomes 9 sevenths. I got 28 fifths minus 9 sevenths. Now I need to force the two denominators to match, okay? So again, I'm just setting this up. I got two fractions and then a subtraction sign between. Just a little bit more clear. There we go. All right, so same method that we saw in that last problem. To force the denominators to be the same, I'm going to take my 5 denominator and scale the second fraction, numerator and denominator, by 5. So in the numerator, I got 9 times 5, which is 45. And in the denominator, I got 7 times 5, which is 35. Okay, so now again, since I'm already seeing this denominator of 35, I should expect this other denominator to be 35 right now. So I'm going to take my 7 denominator from the second fraction and multiply it by the denominator and numerator of the first fraction. And again, we can see in that denominator, 7 times 5 is, 35, just like we expected. But in the numerator, I got 28 times 7. I'll stack and multiply these. So in the ones place value, 8 times 7 is 56, carry the 5. And then 7 times 2 in the tens makes that 14, but adding 5 make that 196. So I end up with 196 35ths minus 45 35ths. And once again, I'll just emphasize this. These fractions, 196 35ths, 28 fifths, and 5 3/5, they are all the same value, just being shown differently, so that we can force them to do what we want to do and allow us to do what we want to do, okay? And then 45 35ths, 9 sevenths, and 1 2 sevenths, they have all the same values. It's just that we're forcing them to be shown a little different. So now, once again, please, I would recommend not skipping this step, but I'm still dealing in 35ths here. The operation is subtraction. I'm just going to take my 196 and subtract 45. Okay. Now this will still be in 35ths. So there's my denominator. I just need to take my 196 and I need to subtract that 45. So in the ones place value, 6 minus 5 is 1. In the tens place value, 9 minus 4 is 5. And then I'll drop the other one, 151. As my numerator, 151 35ths. And then the last thing I need to do on this, just to check to see if it can be simplified. 35 is divisible by 1, 5, 7, and 35, but 151 is divisible by none of those, which means that this is my final answer here. So that was addition, then subtraction. Of course, now we're looking at some multiplication, just like we've seen before. The only difference now is that these two mixed numbers are, they're mixed numbers. We're just going to change these to improper fractions and then operate. So nothing else is going to change really in terms of what we're doing. Let's go and change these into their improper fractions, okay? So I'm going to get 2 more fractions out of this, And I will put them in parentheses just to keep the format the same, although you wouldn't necessarily need to. Now the first mixed number, I got negative 3 and 5, 6. It's negative. I'm going to apply that to my numerator, all right? So I don't have to worry about it being negative or having it there in the end. Now I can apply my mixed number cycle method. There we go. So I'm going to start with 3 times 6, which is 18. And then add the numerator 5 to give me my new numerator. 8 plus 5 is 13, carry the 1. In the tens place value, 1 plus 1 is 2. So I end up with negative 23, really. And I probably should have done this already, but the denominators will stay the same. So I got sixths and fourths right there. And then I need to apply cycle method to my 2 and 1/4. So that's 2 times 4, which is 8. And I will add the 1 numerator. 8 plus 1 is 9. So I end up with 9/4 for my second fraction. Like I said, if you want to multiply these and simplify, that's fine. But you're going to end up with some pretty big numbers. And I really would like to not have to deal with big numbers right now. So I want to see if there's any cross simplification I can do. And there is. I see that the 9 and the 6 are both divisible by 3. So I will do that. I know 9 divided by 3 is 3. And then 6 divided by 3 is 2. So now the problem becomes negative 23 times 3. And then 2 times 4. In the denominator, what do we get on that? Still a fraction, by the way, but I'll do the denominator first because it's easy. 2 times 4 is 8. That's my new denominator. And in the numerator, I got, I'm not going to show the negative. I just know it's going to be a negative. Then I can just focus on 23 times 3. So in the ones place value, 3 times 3 is 9. In the tens place value, 2 times 3 is 6. So I end up with negative 69/8. And if this could be simplified, it would. 8's only divisible by 2, 4, and 8. Negative 69 is divisible by none of those, which means this is our final answer. Yeah, when you put this into Canvas, first of all, if you're writing this by hand, I should say first, some people like to write it like I did here. Now this means the 8's positive and the 69 is negative. Some people like to write it like this, the negative 69/8 with the negative in line with the fraction. That's fine. When you put this into Canvas, technically speaking, we would make the numerator a negative like this. So when you enter this into Canvas, you would write negative 69/8 like this. And then this would give you full credit. Do not assign the negative to the 8 because we want it assigned to the numerator, formally speaking. Now, that doesn't mean that it gives you a different value. It just means that formally speaking, we want the negative with the numerator. Yeah, this one is division, and yeah, the second fraction here, the divisor, is already a fraction, so there's no need to apply cycle method on this one, okay? But I do need to apply it to the 4 1/2. Yep, that's true. So let's go ahead and do that, and well, let's go and write our, because we know we're going to get 2 new fractions out of this. Again, I'm not interested right now in changing the operation to multiplication, although you could with that keep, change, flip business. But I know that the 4 1/2 is negative, so I'm just going to apply that negative to my numerator right now so I don't forget it, okay? And then I'm looking at some cycle method here. So that'd be starting out with 4 times 2, which is 8, and then adding my numerator 1. 8 plus 1 is 9. So again, it's not just that it's 9, it's negative 9. And yeah, once again, I should have put my denominators in here just so I didn't forget those, but there they are. Okay, first mixed number had a denominator of 2. The second fraction has a denominator of 8. So there they are, written in. And yeah, the second fraction, by the way, is already 3/8. That's a proper fraction, so I just want to keep it proper, no problem. Okay, so a little bit less steps right here, but again, it's not that having the second number as a mixed number is more work. It's not that it's more hard, it's just that it's more work, that's all. All right, now that we've done that, what I'd like to do is take my division, because I don't want to divide. I would rather multiply with fractions. So there we go. As long as I do that, or if I do that, then I need to reciprocate that second fraction into 8/3. So I'm going to take my original fraction, negative 9/2, and now I'm going to multiply by 8/3. This is the same problem. It's just shown a little differently. Yeah, we can't do that because we can change the operation because it's one of our math principles on this case. So it's not changing the actual values It's only changing the way things look. And we can do that even with operations like that. So now that this is multiplication, let's go ahead and multiply these out. But before I do that, I know that there's one negative on this with the -9. So I know my answer will be a negative. I'm going to apply it to the numerator, although you don't necessarily have to. But I do see some cross simplification in two cases right here. I see the 9 and 3. 9 and 3 are both divisible by 3, so that's what I'm going to do. I'm going to divide them by 3. 9 divided by 3 is 3 in the numerator. In the denominator, I got 3 divided by 3, which is 1. And then I got the 8 in purple and the 2 in black. Those are both divisible by 2, so let's go and divide those. Okay, so 8 divided by 2 is 4. And then in the denominator, 2 divided by 2 is 1. Okay, so what do I get out of this? In the numerator, I would have 3 times 4. It's already a negative, so I'm not worried about that. 3 times 4 is 12. In the denominator, I got 1 times 1, which is 1. Now, once again, do not write that into Canvas as -12/1, because it is technically not considered fully simplified. It's not simplified until you get rid of that divide by 1. It's still there. It's just we don't want to see it, which would then make it fully simplified. So I end up with negative 12 on this one. That would be my final answer. That's all I would have to type into the homework on the Canvas. And do keep in mind there's at least a few, I think, on Canvas that are just whole values like this. Otherwise, you'll see pretty much all the other answers are improper fractions. No mixed numbers for the homework, okay? Well, here's our objective. I can change mixed numbers to improper fractions and then operate. And remember, with that operation stuff, all the same rules apply. With addition and subtraction, you need common denominators. With multiplication, you do not. And we always change division into multiplication as well. Okay, but we do not want the answers changed back into mixed numbers. Do not worry about that.